Hi, this is Jonathan Janos, Senior Solution Architect at MongoDB, and in this video and demonstration, I'm going to explain how you can use MongoDB to provide self-service data access to your internal and external customers. If we think about modern-day expectations, we realize that self-service data access has become the norm. We want to find data of interest on our own without having to contact anyone. Once we find it, we expect that data to be current. We typically use highly tailored data applications and services that are constantly being updated with new features. And we take it for granted that these services are always on, they're fast, and they're accessible wherever we go from a variety of devices. So why is it so hard to deliver on these expectations? Well, here's problem one. The data in question is probably spread out across 20 different systems of all different shapes and sizes. Some of these systems might be newer, but others might be 30 years old. And when your data is spread out like this, it becomes very difficult to provide self-service data access. And in fact, it can be a deal breaker. Best case, your customers are going to 20 different locations for all the data they need, integrating it by hand, or they're picking up a phone so someone on the inside can do it for them. Worst case, they just can't get it. To them, the information is inaccessible. To solve this problem, organizations will create something called a single view system. A single view system simply pulls data from many different source systems into a single data repository, creating a holistic view of some entity. So maybe it's a customer 360 system if you're tracking customers, or it's a 360-degree view of some other entity, whether that's a computer network, or a supply chain, or a smart home. It's all the same idea. And this single view concept is a key enabler for providing self-service data access. And once you have it in place, you can use it in a number of different ways. You can have dashboards and reports. You can build those highly tailored apps and services that we've all come to expect. You can unleash your team of data scientists so they can work their magic with AI and machine learning. And you can start building some really rich data services and APIs that can be leveraged throughout your organization. So there are lots of really good reasons to deploy a single view system. But here's problem number two. If you peel back the cover on these source systems, you discover all this complexity under the hood. A lot of them were built using relational database technology that's 50 years old at this point. And data in these systems is spread out across dozens or hundreds or even thousands of tables. So when you try to pull in data from these systems and integrate it all in some way that makes sense, it becomes very difficult. And in fact, here's where some of these efforts can fail before they even get off the ground. Because they try to create some sort of uber schema that's going to somehow standardize all the data coming from all of these complex systems. And that can take years. And oftentimes, it's not even possible, because the data coming at you is too unique and it's changing too quickly, so you can never really get ahead of it. Fortunately, this is where MongoDB comes in as a great fit for building a single view system. MongoDB stores data as JSON documents, as pictured on the right. This is an entirely different way of managing data, and it has a lot of advantages over the relational model as pictured on the left. JSON can include subdocuments, which makes it much easier to organize and understand the data you're working with. It can also include arrays, which allow you to embed one-to-many relationships inside the document. And finally, the schema of each record can vary from document to document. That flexibility enables you to quickly assimilate non-uniform data from multiple systems, and that becomes a true lifesaver. Let's walk through an example. Let's say you have data coming in from system A, and it's got a simple list of basic character attributes. Now system B comes along, and it's got some unique additional attributes, in this case, a mobile phone number. With MongoDB, that's no problem. We can accommodate these new attributes without having to change any of the records that are already in the system. And that's a fairly simple example, but the differences might be a lot more complex. Let's say a third system comes online, and it looks something like this. This is a more sophisticated way of modeling the data, where there's a one-to-many relationship that can support any number of contact methods. In a relational database, this requires a separate table. In JSON, that can be represented using an array, and the one-to-many relationship is embedded within a single document. Once again, even though this data is a much different shape than the data from the other two systems, MongoDB has no problem pulling it all together within a single collection of documents. Now you may be wondering, can you still query and analyze this data when it all looks so different? And that's a valid question, but the short answer is yes, and it's something we're going to look at later on in the demo. So here's what a single view reference architecture with MongoDB might look like. To bring data in from the source systems on the left, you've got your typical range of options. You might have an ETL tool like Informatica or Pentaho, and those types of systems all have connectors to push the data into MongoDB. Another option is if your data source has a change data capture capability, then whenever there's a change, they can simply forward that change directly to Mongo. The third option is actually what I'll be showing you in the demo. It's where you've got streaming data coming at you from something like Apache Kafka, and we've got a nice Kafka connector that lets you pull real-time data directly into MongoDB without even doing any coding at all. You just set it up using a simple configuration file. Once we've done that, I'll show you what the data looks like in MongoDB, and then I'll show you how we can quickly access that data using dashboard and reporting tools. The BI tool I'll be using is MongoDB Charts, but we also have a BI connector in case you've already standardized on some other tool such as Tableau or Cognos. Now, as we discussed, what people really expect these days are highly interactive, data-driven apps and services that are really tailored to the types of data and use cases that they'll be supporting. And that, I'm going to show you, is something that is also much easier to do with MongoDB, and it's a big reason why MongoDB has such strong market adoption. Because if you're working with relational databases, it's actually pretty hard to innovate. Let's take an example. Let's say you've got this simple web form that's capturing first names and last names. But then a new feature request comes in, and you have to also start collecting contact information. How would you do it? Well, the first thing you do is add the new fields to your form. But that's a simple change. That's something that your developers can knock out in a few minutes. That's not the end of it, however, because the next thing they have to do is change the backend database schema so there's a place to actually store the new information. That means you have to call the DBA, you set up a meeting for next week, the DBA takes a look at the big schema design that's hanging across their wall, ends up creating a new table or modifying some existing ones, and then you're still not done because you still have to update the translation layer that maps the fields in the form to the new tables and columns in the database. And then you have to figure out how you're going to deploy all those changes. Now, this is a very simple example, but over time, it gets more and more complicated, and you're left with this massively complex system. It's much easier to innovate with MongoDB. Let's take the same situation. You've got this web form, and you need to add a few new fields. So your developers make their changes just like before, but this time, they make their changes, and they're done. No changes to the backend database. And this is why developers love working with MongoDB. I'll show you how this works in the demo. Okay, so let's get to it. Let's take something topical. Let's say you're looking at COVID data, and not surprisingly, if you go to all the cities and states, you notice they all report the data a little differently. Here's how Washington, D.C. reports it. Very clean, very sensible. D.C. is divided into sections called wards, and they're reporting the daily case counts across all the wards. Now here's New York. Also clean, also sensible, but different. New York has the case counts broken out by borough, so here we've got the counts for Brooklyn and the Bronx, and off to the right you'll see Manhattan, Queens, and Staten Island. There are differences in the names of the columns and the formatting of the dates. They're also providing hospitalization and death counts, two additional metrics that aren't present in the DC dataset. Now here comes Louisiana. Louisiana reports things by parish, so we've got 5 of them here, and then there are another 50 or 60 of them off to the right. We'll have lots of these datasets coming in from all over the country, and we can assume that all of them are going to be unique in some way. So how do we bring everything under one roof so we can provide customers with self-service access to this data in a time frame that reflects the urgency of the situation? Coming up with a comprehensive, standardized schema is going to be tough. If we're looking at lots of cities, lots of states, that's going to take a long time, and we probably won't be able to keep up with the inevitable changes. We don't want to drop anything. We want to bring in whatever metrics are being reported. At the same time, we want to bring it in a way that's useful, that's going to allow people to query across the different datasets and do meaningful analysis. So here's what we do. We say to ourselves, let's prioritize what data we want to provide. It takes too long to standardize everything, so let's just focus on what our customers really need and what we can deliver today. We can always improve things as we go. So let's focus on where the data came from, the date, so let's make sure that's all standardized, and let's look at the total case count. That way, our users get fast access to the most important data we've got, and at the same time, we'll keep all of the data, so if people really need it, they can always go in and take a look. So let's see what this looks like. Here I'm going to kick off our data feed, and you can see the data start to come in. If you keep watching, you'll see that the data suddenly changes. The data is different depending on the source system it's coming from. We're taking this in through Apache Kafka and pushing it directly into MongoDB using the MongoDB connector for Apache Kafka. This is all done through a simple configuration file that looks something like this. There's no coding at all. You just say, I want to listen for any data having to do with COVID. I want to connect to this MongoDB server and write to this collection in this database. So what does this data look like in MongoDB? Let's pull up MongoDB Compass, which is a great tool for checking out the data that's in your MongoDB databases. Let's take a look at New York City. I'm going to add a simple data filter. This is using MQL, the MongoDB query language, and here's the New York City data. Here are the fields we standardized on, the source, the date, and the total case count. But if I look here, I see there's also some nested data, and that's all the data that's coming in that's unique to New York. So I haven't lost anything. Now let's take a look at DC. I'll switch my filter, and here's what DC looks like. Again, I've got my standardized fields up top, but underneath, I've also got all the data that's unique to DC. To see how really useful this is, let's switch over to MongoDB Charts, where we now have immediate self-service access to this information. Here I'm in the chart builder, and I'm going to point to the data we just brought in. When I do that, I can see my top-level attributes here, which are the fields we chose to standardize up front: the source, the date, and the total case count. Let's make sure Charts correctly interprets this field as a date and the case counts as a number, and then we'll build a simple line chart. Once I set the chart type, I can just drag the date over to the x-axis and drag the counts over to the y, and I see my data start to take shape. One more step to specify a separate line for each location, and now we can see how events unfolded. Here's New York peaking early, and here's a resurgence developing in Louisiana. But the worst seems to be DC, even though I know the situation in DC is better than this graph would indicate. So what's going on? It looks to me like the DC numbers might be cumulative counts, which would be inconsistent with the daily counts being reported elsewhere. So by bringing the data in sooner rather than later, we might have just identified a potential data issue. If we assign an analyst to investigate, that person will likely want to review everything DC sent over. A lot of that hasn't been standardized yet, but thanks to MongoDB's flexible schema, we still have complete access to it. Here I am again at my chart builder, and along with my standardized fields, I note that this attribute is a nested subdocument that contains all the additional details that may be unique to just one city or state. Expanding on that field, I'm able to locate the metrics for each ward in the district and quickly drag them onto my chart for further analysis. So we can bring the data in quickly, add a lot of value up front by focusing on the key pieces of data to standardize, and also keep the remaining non-uniform details in case somebody knows what they're looking for or needs to take a closer look. And of course, we can continue to refine this model as our needs evolve and as time allows. Now let's go through the development process to see how MongoDB makes it much easier to go beyond simple reporting to building the highly tailored, highly interactive apps that we've all come to expect. Given the data issues we just saw, we decided to introduce a workflow capability that requires sign-off from a data steward before any new data is made available to the public. Here's a simple web form that a developer on our team created, and as a data steward, I can now add my name, note that there are some known issues with this data that are currently under review, and click Submit. We can see this new record in the database using Compass. Note that this collection didn't exist before I saved the first record, and we didn't have to define any schema in advance. Now let's say the developer wants to clean things up a little. This name field is a little ambiguous, so they replace it with two separate fields for first name and last name. Here's the original HTML form, and it's a simple modification for the developer to provide two fields instead of the original one. One more change to ensure the new fields are submitted to the server, and that's it. Now let's refresh our page, and we see our new form. I'll type in my name again, add a reason, and click Submit. Looking at the database, here's the new record with our new fields right where they're supposed to be. No database changes required, and that's why developers are so much more productive when they're using MongoDB. So let's recap. We started out by noting that self-service data access is the modern-day expectation. That can be really hard to deliver when the data is scattered across lots of different systems. So, you can deploy a single view system to consolidate all the data of interest into a single repository, which you can then use in a lot of different ways. It's hard to make all the data look the same, so use MongoDB. Its document data model is really well suited for this use case. You can ingest the data in lots of different ways, store it in MongoDB, and then access the data using standard BI tools or new data-driven applications and services, which you can build a lot faster on MongoDB because it's a much easier way to work with data. We put these ideas into a demo based on COVID data from a couple different places, showed how you could quickly ingest and query across these non-uniform data sets, and then made some quick real-time improvements to a notional workflow application. Thanks for watching. I hope you're able to use this information to build better self-service data applications that deliver great experiences for all of your internal and external customers.